let us discuss the multi-dimensional data model. See, nowadays we have so much of data. We need to understand the data into different dimensions. Like if we have a customer, we need to analyze that customer on the basis of how much purchase does that make, to which area does he belong, at what particular point of time he makes more of his purchases. So for analyzing a customer, we need to have different dimensions to analyze one customer. So that is why we use here the multi-dimensional data model. The multi-dimensional data model, it is a method which is used for ordering the data in the databases along with good arrangement and assembling of the contents in the databases. The multidimensional data model, it allows a customer to interrogate the analytical question associated with the market or the business trends. This multidimensional data model, it will allow the user to rapidly receive the answer to the request which they made by creating and examining the data comparatively fast. That means we can use this multidimensional data to retrieve any answer to the query at any particular point of time. So our online processing that we have just studied about and the data warehousing, they use the multidimensional database. It is used to show the multiple dimensions of the data to the users. Whosoever is using that data, whether a marketing person is using that particular data that is retrieved in the form of report using the business intelligence system, a salesperson is using that, a CEO is using that for making further strategies. So they can all access the different dimensions of data using this multi-dimensional data model. It represents the data in the form of data cube. Like we have a cube, you must be knowing what a cube is. We can view the cube from different direction. This is the top direction, this is the top one, this is the bottom one, this is the left side one, the right side one. So the data cubes, they allow to model and view the data from many dimensions and from many perspectives. It is defined by dimension and facts, and it is represented by a fact table. Facts are like, we can say, numerical measures, and fact tables, they will contain measures of the related dimensional tables or the names of the facts. So we have an entire multi-dimensional data model. Like if we have to analyze a customer, suppose that customer, he has made no purchase in the month of January. So we cannot declare that this particular customer, he is not making any purchases. Let us remove it from our list. No, we have to analyze that whether that person, that customer is making some purchase in the month of February, March, and when is it making. If a customer is purchasing one product at this point of time, so we cannot say that he does not purchase the other product. We have to analyze that at what point of time that customer is making purchase of that product. So whenever we are analyzing our data, we have to analyze, we have to think of various dimensions to analyze our data so that we can make better strategies for our businesses. So that is why we consider here multi-dimensional data model, where we are trying to see the different dimension of the data to make better strategic decisions. Now, let us understand this multi-dimensional data model with the help of an example. Like here, I am talking about different dimensions. So what does that mean? For example, let's take the example of the data of a factory which sells product per quarter in Bangalore. Suppose the location that we're considering here is Bangalore. We are talking about a factory which produces different items, like it produces jam, bread, sugar, milk. These are the items that we want to analyze. Then we have divided it into the quarters. We have divided our time. At what point of time, what is being purchased? So we have divided our entire year into 4 quarters, like January, February, March into first quarter, April, May, June into next quarter, July, August, September into next, October, November, December into next quarter. So we have divided our entire year into 4 quarters. Now, in the given representation, like you can see, the factory sales for Bangalore are for the time dimension, which is organized into quarters, and the dimension of items, which is sorted according to the kind of item which is sold. So the facts here, like we have 350 in quarter 1, 350 the gem, that how much gem has been sold off. We are calling in quarter 1 in Bangalore, the jam packets that have been sold, it is 350. So 350 is our fact. This we can say in thousands or in whatever quantity you want to say. 350 thousands. Then we have 250 in quarter 2, 1000, 250,000. So this facts we have kept in the terms of 1000. This 350 does not mean 350 gems have been sold from the factory in quarter 1. 350 and we multiply it by 3 zeros, that means 350,000. So that is how we analyze our data. Now here we have considered the location as Bangalore. We are talking about the factory in which the items sold are jam, bread, sugar and milk. And we have divided it into different quarters. That is a time dimension. So we are viewing our data for the location of Bangalore and we have divided it into the time dimension. We have divided into 4 quarters. Now, if we desire to view the data of the sales in 3-dimensional table, this is a 2D table. Now we want to represent it into the 3-dimensional table. Then we can represent it like we can take one more category. Here the data of sales, it is represented as 2 dimension. Now we let us consider the data according to the item, time and location. In that we have taken only 2 dimension. One is the item, another is the time. Now we are adding one more dimension to it, that is the location. So our 3D table, how will it look? It will look like this. We have the location, Kolkata. Then we have the items, we have milk, egg, bread, whatever items, jam, whatever items you can have. Then we have divided it into the time, into different quarters, Q1, Q2, Q3. This is just an example. You can divide it into 3 quarters. You can also divide it into 4 quarters, depending on your requirement. Similarly, the items, do we want to take 3 items, 4 items, 5 items? What all do you require? It is just an example of that. We have taken the location as Calcutta. That is one dimension for us. The second location is Delhi. Third is Mumbai. So that is why we are talking about the 3D view. What all 3 things we have here? 3 dimensions that we have here. First is the time that we have divided into quarters. Second, we are talking about the items. Like the second dimension for us is the item. Milk, egg, bread, jam, whatever items we have. Then what is the third dimension that we are talking about here is the location. Like what is the location that we are talking about? The purchase of, the location is Calcutta, Delhi, Mumbai or Bangalore or whatever the location is. So that is what we have. We need to see our data from different dimensions. So that is why we need to do multi-dimensional analysis. Now this data, it can also be presented in the form of 3-dimension conceptually. Like we can also view this data in the form of cube. Cube, we see on the cube, on one side we can take the quarters, the time. On the other side we can take the location. On the next side we can take the items that we are selling. So if we want to analyze the data, we can analyze it in the form of cube. Like if you're talking about a particular sale in the Mumbai, so that particular Q points will be taken for quarter 1 and what all items are purchased. So this entire data which we have represented it here in the form of table, it can also be represented in the form of cube for better analysis. So that is an example of our multidimensional data model. Now we are talking about some of the terms that we use when we make the data analysis. First of all, we are going to talk about two important terms. One is an attribute, second is a hierarchy. Attribute, you can say it is a feature. Attributes in data analysis or data mining, whenever we are trying to extract the data. An attribute is a characteristic or the feature that is measured for each observation or for each record, and it can vary from one observation to another. It might be measured in the continuous values, like the time spent on a particular website. It will be a continuous value, or in the category value, like we have red, yellow and green. Let us understand this attribute in the form of an example. If we are analyzing different balls. Now what all attribute our ball can have? We can talk about the color of the ball, that what is the color of ball? Is it red? Is it green? Is it yellow? So that is one attribute of the ball. Then we can talk about the size of the ball, whether it is small size ball, medium size ball or a big size ball. So these are the attributes that we can use for the analysis of that ball. So attribute, it is a characteristic that is measured for each observation. If we are trying to make some observation for a ball, what attributes we can say? If we have a ball, what is the color for it? What is the size of it? Similarly, for which sport the ball is going to be used. That can be another attribute, whether it is a TT ball, it is a football, it is a basketball, what sort of ball it is. That is another attribute that you can add. So attribute is a feature that is used for making the observation. Second, another term that we use when we analyze our data, that is the hierarchical data. Hierarchical data, it is a data structure where the items are linked to each other in a parent-child relationship in an overall tree structure. Now let us understand this. Hierarchical data, hierarchy, starting from top going to bottom. Think of a data like a family tree. If you're talking about a family tree, we start from the grandparents, then we have the parents, then we have the children, then we have the grandchildren. It forms a hierarchy of connected data. Now typically this is used to show an organizational chart, a project with tasks. If we want to represent a particular project, we have different tasks in it. Suppose in an organization, a particular project is assigned to you, that you have to make this project. Now you have to make some hierarchy for that. That if there are different processes in your project, so this should be done first. After this, next, this can be done. After this can be done. So we form a parent-child relationship. We form a hierarchy of tasks. So that is why we use this hierarchical data. In hierarchical data, each of these children nodes, whatever children we have, they have only one parent. One children here, it cannot belong to two parents. But each parent, it can have multiple children. The first node at the top of the hierarchy, that is known as the root node. When the information it needs to be retrieved, the whole tree is scanned from the root node down. We start from the root node, we go down to analyze this whole information. Since the whole tree, it needs to be scanned, each time a user makes an query, it makes for an inflexible, slow system. So now the modern databases, they have evolved to include the usage of multiple hierarchies over the same data for faster and easier searching. Today we are using this hierarchical data concept. So this hierarchical data concept, it can be used into our databases, into our data warehouses, so that we can analyze the data easily. So this attribute and hierarchy, these are the two terms that we use to analyze our data. Then we have one more thing here, dimension. Dimension is the structure which categorizes the facts and the measures in order to enable user to answer the business question. What all dimension we use? We can use people, we can use product, we can use place, we can use time. Like we have seen in our previous example, if we were studying, if we are talking about the sale of a factory, what all dimensions had we taken? We had taken the dimension of time that we divided into different quarters. We have taken another dimension, that is a location. So dimension is what? It is a structure which categorizes the facts and the measures in order to enable the user to answer the business questions. In our data warehouse, the dimensions, they provide structured labeling information to otherwise unordered numeric measures. The dimensions, it is a data set composed of individual non-overlapping data elements. A common data warehouse example, it involves sales as a measure with customer and the product as dimension. If we are talking about a common data warehouse, it will involve the sales. What is our measure? What are we measuring? We are measuring that sales part, that how much sales has been done. Now our dimension, it can be customer. It can be the product, that which product is being sold more. So that is an example of dimension. In each sale, a customer, he buys a product. The data, it can be sliced by removing all the customer except for a group under study. And it can also be diced by grouping different products. We will be studying the concepts of this slicing, dicing in the upcoming chapters. Typically, dimensions in a data warehouse, they are organized internally in one or two hierarchies. Suppose date is a common dimension with several possible hierarchies. If you are talking about date, now date, it can be grouped into months, which can further be grouped into years. So that is one hierarchy for days. Days, months and years. Talking about another hierarchy that our days can make. Days, they can be grouped into weeks. Now these weeks, they can be grouped into years. That is another hierarchy. Now days, they can also be grouped into months, which can further be grouped into quarters. And these quarters can be grouped later on into years. So dimension in a data warehouse, they are organized internally into one or more hierarchy. We can use different hierarchies for organizing our data. So this is the second concept, second term that we should understand. When we are talking about the data analysis in our business intelligence system, we should be knowing these terms that we are using. What do we mean by attribute? What do we mean by hierarchy? What do we mean by dimension? If we are aware of these terms, then only we can apply these terms into our intelligence systems. Now, let us understand one very important term here, that is data warehouse. This data warehouse, it is a central part of our intelligence systems. Data warehouse, it is a relational database that is designed for query and analysis rather than the transaction processing. It includes the historical data that is derived from the transaction data from single or multiple sources. A data warehouse, it provides integrated enterprise-wide historical data, and it focuses on providing support for the decision makers for data modeling and analysis. So basically, it is an integrated support which will collect all the historical data, and The historical data, it will be used for the decision making after modeling it, after analyzing it properly. A data warehouse, it is a group of data specific to the entire organization, not only to a particular group of users. It is basically a group of data that is specific to the entire organization. Generally, a data warehouse, we do not use it for the daily operation and the daily transaction processes, but we use it for a wider scale, for making decisions. If we are talking about data warehouse, then all the transactions that are being taken place, they will be stored in the files. Now, these files will be extracted properly and then loaded into our data warehouse. So, our data warehouse, it will not have all the daily operation, that what on the daily basis, what all purchases are being done. It will not hold those things, but they will be used for making better decisions after analyzing those daily operations. So, if we talk about the main definition of data warehouse, it is a subject-oriented, integrated and time-variant store of information in support of management's decision. So, data warehouse, it is subject-oriented. That means it will focus on a particular subject. It is subject-oriented. That why is this data warehouse being used? It is integrated because we have number of things integrated together into our data warehouse. And third important thing, it is time variant. That means it is not that so that we have stored a particular information into our data warehouse and it will remain true forever. No, it is time variant. It will vary with time. Like if we are analyzing the buying pattern of a customer from our data warehouse to make a better decision for him. So what we do, we analyze his data pattern, but it is going to be time variant. We cannot say that this particular person, he purchased this product at this point of time. So it is true forever. Forever this is true for that customer. No, it is time variant. We have to again and again access the data and vary our data warehouse according to that, so that we can take better decisions using those data warehouse. So basically, data warehouse, it is a subject-oriented, integrated and time-variant store of information and supports of management decisions. It provides us the integrated historical data and it focuses on providing the support for the decision makers for their analysis, for their modeling of data. So basically, data warehouse, how we can understand this? It is a relational database which is designed for query, for making some query. If you want to ask the question about any particular customer, so it can be used for that. And for analysis, we can use that rather than transaction processing. We do not use our data warehouse for making the daily transaction, that these items are being sold today. That information we will not keep into our data warehouse. It will extract information important that is to be stored in the data warehouse. So in our data warehouse, the daily transactions, they are not stored. They are stored in different databases into different files. Using those databases and those files, our data warehouse, it will extract and it will transform that information so that the information which is kept into our data warehouse now, it is a better use for analysis. It can be better used for making management decisions. So data warehouse, it is a subject-oriented, integrated and time-variant store of information in support of the management's decisions. If we talk about the architecture of data warehouse, then how does our data warehouse look like? So see, first of all, in our data warehouse, the main content is the central part, which is a warehouse itself. So it has to get some input from some resources. Some sources should provide the data to our warehouse. So those sources, they can be the operational systems, or they can be the files, simple flat files, which store the daily transaction. So when we are talking about the data warehouse, the input it will take is from the sources, which can be the operational system, which can be the flat files, which can be some spreadsheets, which can be any sort of files which will hold the daily operations data. Then we have our warehouse. In our warehouse, we can store some raw data. Now, using that raw data, we can achieve some summarized data too. That whatever raw data we have received, we need to summarize that data into few points. And using that summarized data, the data can be retrieved from the warehouse. Now, there is one more part of it, that is metadata. This is one particular part of it, metadata. It will say, what does this metadata mean? Data about data. Sometimes, for some important data, we need to store some related information. So, that is known as metadata. Data about data. So, that is also a part of our warehouse. So, our warehouse, what will it contain? It will contain the raw data, which is their general data that we have received, the summary data, which is the summarized form of our data, and also the metadata, which will include some of the references for our data. Then we have the users. They can analyze this data, they can make reports from our data, or they can also use this data warehouse for the purpose of data mining. So the input that is for the warehouse is the operational system and the flat files. And the main data warehouse, it will contain the metadata, it will contain the summary data, and it will also contain the raw data. Now this data, it can be used by the users for the analysis purpose, for making some form of reports, for the reporting purpose, or for some mining purposes. Mining purposes means if you want to extract some important data from there. So for data mining also, we can use that data from the warehouse. So this is the general form of architecture of our data warehouse.